The succession of Point Pleasant forests following Hurricane Juan in 2003.
Point Pleasant Park, a cherished green space in Halifax, Nova Scotia, suffered significant damage during Hurricane Juan in 2003, leading to an 8-month closure and sparking scientific interest in studying urban ecological recovery processes within this park. This sparked Dalhousie University's Bio 2060 students to investigate the storm's ecological impacts and specifically its recovery via secondary succession by establishing multiple study sites in heavily affected areas of the park. They collected the diameter at breast height measurements, or DBH, of 2.5 centimeters or greater within the evergreen forest tree populations in Point Pleasant Park, which is a widely used forestry metric that provides insights into the forest ecosystem's growth and health post-hurricane. Looking at past studies, a paper from Eunice et al. From 2020 examined the post-seismic landslide evolution following the 2008 Wenchuan earthquake, emphasizing environmental succession's role in assessing when ecosystems return to pre-disturbance states, allowing communities to determine when important ecological services might return to their community. Similarly, an investigation from Lane et al. In 2021 measured the growth of different peatland species post-environmental disturbance to understand ecosystem resilience to environmental change. These studies signify the importance of our study, as it will allow us to identify when ecosystem services might return to our park and help organizations create protections for more climate-resilient species within the park, increasing the park's overall tolerance to future climatic disturbances. Furthermore, based on a paper from McDonald in 2016, Point Pleasant Parks, or Amnukati to the Mi'kmaq people, holds cultural significance to the Mi'kmaq as an annual gathering place where they go to celebrate Quoluikwu for 7 days after the first full moon during the spring. This underlines the importance of its conservation, reinforcing the need to integrate Indigenous perspectives into environmental management practices moving forward.
This study aims to identify the stage of succession in Point Pleasant Park, Halifax, Canada, following Hurricane Juan in 2003. This can be achieved by analyzing the diversity of species, the changes in dominant species, and species evenness. Shan's Diversity Index aims to assess the changes in diversity in Point Pleasant Park from 2004 to the present. The null hypothesis is that there has been no significant change in the diversity of tree species in Point Pleasant Park in the year following Hurricane Juan in 2003 till the present. The prediction for the Shannon Diversity Index is that there will be a significant change in the diversity of tree species in Point Pleasant Park in the year following Hurricane Juan in 2003 till the present. Assessing the dominant tree species, red maple and red spruce, aims to assess how the abundance of Point Pleasant Park's dominant species have changed from 2004 to present day, and how they might change in the future. The null hypotheses are that there is no significant change in red spruce density immediately after Hurricane Juan in 2004 to present, and that there is no significant change in red maple density immediately after Hurricane Juan to present. Our predictions are that there is a significant change in red spruce density immediately after Hurricane Juan in 2004 to present, and that there is a significant change in red maple density immediately after Hurricane Juan in 2004 to present. Pelu's Evenness Index aims to identify the evenness in Point Pleasant Park from 2004 until the present. This is done by determining the rate of change and performing a regression analysis on evenness over time. The null hypothesis for evenness is that there has been no significant change between evenness in 2004 and in 2023. The prediction is that there has been a significant change between evenness in 2004 and the present. To measure the succession of the forest in Point Pleasant Park, Halifax, Canada, after Hurricane Juan in 2003, density per tree species per 400 meters squared and the size in centimeters of each tree were measured. The data was collected from the same 6 plots of forest every year since 2004, as shown here, spread out throughout the park to ensure accurate data. Data was not collected in 2005, 2007, and 2016 due to Hurricane Ophelia, Noel, and Matthew, as well as in 2020 due to the COVID-19 pandemic. The sizes of trees are measured using diameter at breast height, in which the diameter of the trunk is measured with a specially calibrated diameter tape 1.3 meters up from the ground. The data was used to compile statistics for the total density, diameter at breast height, the Shannon diversity, evenness, and dominant species graphs for red spruce and red maple. Linear regressions were used to provide a series of regression diagnostics to quantify relationships, such as the relationship between the years past after Hurricane Juan and variables like species richness and diversity. The data for different statistics can be compared to each other using an R-squared value to see if there are relationships between variables. The accompanying p-value can be used to determine if the hypotheses can be proved or not. Species diversity was measured to compare the abundance and variety of species throughout Point Pleasant Park in Halifax, Canada, following Hurricane Juan, to analyze the changes to the forest as shown in Figure 1. We used a regression analysis to analyze the relationships between species diversity and the years from 2004. The Shannon-Wiener index was used to measure diversity, which accounts for the number of species and their abundance relative to the total population. The results show that over time, the diversity of tree species in Point Pleasant Park have been increasing at a rate of 6% per year from the year after Hurricane Juan in 2003. We reject the null hypothesis that there has been no change in diversity since Hurricane Juan due to the small p-value. Initially after the hurricane, as seen in Figure 1, the Shannon Diversity Index was very low, but increased to a very high diversity rate by 2023. Large disturbances, such as hurricanes, tend to speed up the typical succession rate and diversity of tree stands from Z in 2008. From Turkey in 2016, in the 1990s, Point Pleasant was near its climax community, with red spruce and white pine as dominant species. As the community reaches its climax community, the forest will be mainly composed of older growth species of a diverse Acadian forest, similar to as it was pre-Hurricane Juan.
For results 2 here, we're looking at how the density of the dominant species in 2004, as well as the dominant species in 2023, have changed over time, and how it will continue to change as we move into the future towards the ecosystem's climax community. For Figure 2, regression analysis was used to explore the relationship between red spruce density and time passed after Hurricane Juan in Point Pleasant Park. There was a significant positive relationship between red spruce density and time post-Hurricane Juan, based on the p-value being less than 0.002. And since that p-value is less than 0.05, we can reject our null hypothesis that there is no significant change in red spruce density immediately after Hurricane Juan to present. And then when we move to Figure 3, a regression analysis was used to explore the relationship between red maple density and time passed after Hurricane Juan in Point Pleasant Park. There was a significant positive relationship once again between red maple density and time post-Hurricane Juan, and this time we have a p-value of 0.0001. Again, since it was less than 0.005, we can reject our null hypothesis that there is no significant change in red maple density immediately after Hurricane Juan to present. The density of these dominant species, red spruce and red maple, were decimated following the hurricane. As you can see in Figure 2, immediately after the hurricane in 2004, red spruce density was between 2 to 7 trees per 400 meter squares between all 4 plots respectively, while in Figure 3 there were no red maple across all 4 plots. However, in the years following the hurricane, secondary succession processes began to take place, and in the case of Point Pleasant Park, the red spruce and red maple slowly began to regrow, as seen in Figures 1 and 2. Moving to 2023, whilst red spruce and red maple have clearly increased in density, seen in the graphs below, they have likely not returned to the levels pre-hurricane. Red maple reaches maturity after around 70 to 80 years based on a paper from Walters and Yanni, while red spruce takes 200 years until it reaches maturity based on a paper from the Nova Scotia government published in 2017. Due to these slow growth periods, faster growing fauna will likely share dominance within Point Pleasant Park until these slow growth trees have time to catch up to them, based on a paper from Wodzinski in 2021. As the ecosystem approaches its climax community, these old growth trees will have had the opportunity and time to reestablish their dominance, and the ecosystem will likely return to a similar state pre-hurricane.
This experiment was conducted to measure evenness amongst tree species in Point Pleasant Park following Hurricane Juan in 2003. Density and species identity were used to calculate evenness on an annual basis. The data, along with a regression analysis, is displayed in the figure above. Evenness becomes slightly lower as time progresses after the hurricane, and the R-square value of 0.028 indicates a slight correlation between years past and evenness. However, a p-value of 0.15 at 1 and 72 degrees of freedom indicates that we cannot reject the null hypothesis at a significance level of 0.05. This means that there is not a statistically significant correlation between tree species evenness in Point Pleasant Park and the progression of time. As displayed in the graph, evenness gradually declines throughout the succession process. This can be attributed to the increase in numbers of both dominant species, red spruce and red maple. As these two tree species occupy a greater portion of the forest in Point Pleasant Park, evenness becomes reduced. As the forest moves towards its climax community, it is likely that evenness will begin to plateau as the forest reaches maturity. Succession theory predicts that evenness declines, then increases 5 years after the disaster, then decreases once more before remaining constant. The first half of that trend is visible through the individual points above, as we can see J increase around 2010. The data collected in the 20 years following the effects of Hurricane Juan on Point Pleasant Park demonstrate the regeneration patterns of the forest. The performed regression analyses indicate increases in total population, density, diversity, richness, and gradual decreases in average diameter, breast height, and evenness. Based on the provided data, it appears that the Point Pleasant Park forest is in the late stages of succession. The climax community has not fully been reached, however, there is an increasing abundance of shade-tolerant species, including red spruce. This can be partially accredited to the many regeneration efforts that have taken place over the past 2 decades. Succession can be impeded upon by an urban environment. Anthropogenic activity can hold a negative impact on seed banks, making it difficult for trees and vegetation to grow. Additionally, urban areas pose stressors such as abundant squirrel populations that also infringe on trees' ability to grow. The Mi'kmaq concept of Nitikulink highlights the values of interconnectedness, reciprocity, and responsibility. Our relationship to the land is a large component of this, and Mi'kmaq culture greatly values giving back to the land and fostering a reciprocal and respectful relationship with nature. This applies to the forest in Point Pleasant Park, as the forest is a valuable resource to the people of Halifax. It holds instrumental, recreational, and spiritual value. After the devastation caused by the hurricane, it was important to aid the forest in regenerating itself by planting trees and cultivating healthier soils. This exchange between the forest and people embodies Nitikulink with the interconnected of life on Earth. With further integration of Mi'kmaq values in environmental management, conservation, and regeneration efforts can be strengthened, which will in turn reinforce our ties to the land.
Thank you to the Dalhousie Fall Term Ecology students for continuously collecting the data for tree densities and diameter at breast height. Another thanks to Dr. Allison Schmidt for preparing the data and regression analyses that were used in our presentation.